Okay. Equations. When you solve an equation, you are finding the answer. So at the end of solving an equation, you should end up with something like x equals this, or theta equals that. That's where we're going in this thing. That's what we're going to do. I'll give you an example. I'll give you an easy example first. Suppose I give you something like this. 5 cos theta plus 7 equals 4. Solve for theta. Theta is between 0 and 360 degrees. Notice I don't have the equal sign under this one. So that means you're not supposed to include 360 degrees. That way you just have exactly one revolution. That can change. They can change these numbers where you want to solve it between. So you always have to look at this. And it's a good idea when you get to this type of question, just to highlight that, to remind yourself that you need to look at that at some point in the question. Okay? Now, who has any idea where we're going when we look at something like this? Okay, that makes sense because that's kind of what we did in grade 9 as well, right? We got kind of, this is, yes, so the first step is to solve the equation for cos theta. Okay? So we're going to get cos theta by itself. You following me? So how do we do that?
Subtract 7 from each side.
Subtract 7.
And
5 cos theta equals negative 3. Cos theta equals negative 3/5. Good. That's step 1. Okay, so in this case, step 1 was fairly simple. Right here, this is all step 1. Here's step 2. Okay. Find reference theta using calculator or unit circle. Okay? Depends whether it's an exact value or not. Is 3/5 one of those values that we had?
No.
No. We had things like 1/2 and root 2 over 2 and root 3 over 2, right? We didn't have things like 3/5. So we're going to have to use our calculator. Do you remember how you use your calculator to do this? Remember how that? Okay, we do this button, remember? Cos inverse of 3/5. Second function, right? This little negative 1 means the opposite of. It means the inverse function of. It makes sense, right? In solving equations, the opposite of adding 7 was subtracting 7. The opposite of multiplying 5 was dividing by 5. So now we got to do the opposite of cos, which is cos inverse. Does that make sense? Now notice I ignored the negative sign. I did not use it when I put it into my calculator. Right? What did you get for an answer? So the reference theta equals 53.313, or what is it?
130.
Oh, 13. Okay, I knew there was that. And that's degrees, right? You get step 2. You did that last year, right? Now that you see it, bringing back memories. Okay. Step 3 is this. We draw the angles into the proper quadrants. step 3, we use the quadrants. Mark? Yeah, ready? So here's the thing, people. This is the part that's really important here. When we draw these, where do we draw them? Well, we have to go back here and say, we have to draw them where cos is negative, because this says the cos of this angle produces a negative value, right? So we need to draw where cos is negative. So where is cos negative? 2 and 3. So that's why we have to draw them there, right? Do you get that? If we drew them here on the right-hand side, they would give us this 3/5 value, but they would give us the positive 3/5, right? We don't want the positive 3/5, we want to produce the negative 3/5. So that's why we draw them here. Does that make sense? Okay. If I would draw all the angles at a 53.13 as their reference angle. Notice, by the way, you draw it from the x-axis. It's always drawn kind of like a butterfly. That's kind of the way I remember it. Okay? These angles will all produce the 0.6. Every one would. But this would produce a positive 0.6, and this would produce a negative 0.6. 3/5 being 0.6, right? You follow that too? Well, 3/5 is 0.6, right? So if you took these angles and you put the cosine, we'll do it at the end here. Okay, I'll show you how it works. So look. So now the step 4 is to state the final answers using the given domain. Our domain was this. Our domain was from 0 to 360 degrees, right? That's where all of our answers are supposed to be between. You get that? That was stated in the beginning, right? So this is always stated at the beginning of the question. So, in other words, we know that we're supposed to be 53.13 degrees away from this line, but what is that line? That's 180 degrees, right? Right, that's what that angle is. So then theta, we give our final answers here. Theta is going to be 180 take away 53.313. So that's 126.87. Right? Or 233.13. So now, Taylor, if you would take the cosine of 233.13, you should get an answer that's close to negative 0.6, because that's what 3/5 is, right? Does that make sense? Whereas if you had done the same thing over here, your answers would have been close to positive 0.6. Does that make sense to you, Taylor? Okay, because we needed to be where cos would produce negative values. That's why we had to go over here. So that's what you did last year, right? Okay? Is that okay? Do you kind of get steps? Well, today it's not going to go much different. The process is going to be the same all today, except that some of your questions will be in radians. Okay?
We gotta convert it.
Well, you have two options. You can do it exactly like degrees, and then multiply by pi over 180 at the end. That would be a way of getting around having to work with radians. But most of you will find that after a while, once you get more comfortable with radians, it's easier just to work through with radians. All you actually do all you have to do is just change your calculator to radians, and it will do all the rest for you.
Is that what that RAD means?
Yes.
Oh, wow.
Okay. Let's do one like that in radians then. Okay, so here's the next question. Solve for theta, where theta is between 0 and 2 pi. Okay, so as soon as you see the 2 pi, that is your big hint. That means radians. So all you do is you change your calculator to radians. Does everybody know how to do that on the calculator? Okay, I'm going to pause it a little bit, and we're all going to get our calculator to radians. All right, we're all in radians, so now we can continue. Remember, step 1 was to solve the equation. This time we're going to solve the equation for sine theta. So it's like pretending that the sine thetas are x's, right? People? It's really like solving, if you want to think it in your mind, you're solving this equation. 3x squared minus 2x minus 1 equals 0. That's what you're trying to solve. Get the x by itself, right? Do you know how to solve these types of equations?
More or less.
You should. You told me the other day you did do quadratics.
Yes, sir. Pretty much know how to do it.
Exactly. So this is
That kind of
question. What's our first line of defense against a quadratic? What's the first thing we try to do? Factor. Yes, break it down. And if we can't factor, we resort to the quadratic formula. So if you're not good at factoring, you've got to use the quadratic formula. This is a pretty simple factoring because this is a prime number, that's a prime number, so it's not going to be too complicated.
What do you do if the 3's in the front again? Because you can't factor right away.
You can factor right away, actually. I'll show you how.
Yeah, 3.
We're not going to make them too hard, okay? We're not going to make them super difficult where you have to do a lot of complicated stuff. But 3 is okay because it's a prime number.
Okay.
There's only one way to get that, and that's by going 3 sine theta times 1 sine theta, right? That will get you 3 sine squared theta. Does that make sense?
Yeah.
And there's only one way to get the 1 in the back end, right?
Yep.
You can only get it 1 times 1. You agree?
Yeah.
Remember, the front, you have to multiply to the front, the back to the back.
Yeah.
The middle is the complicated one because the middle comes from these two together, right? But that's going to be okay because I'm going to have a 3 sine theta and a 1 sine theta. And that'll give me a 2 in the middle if I negative 2. So which one's going to have to be negative?
The right one.
Good. Negative, positive. You see how that works?
Good guess.
So that, you're supposed to know from 11, but I know it's kind of weak. People kind of forget that after a while. But you at least are familiar with it, right? So now we're to step, but we still really haven't solved for sine theta. We still haven't got sine theta by itself, have we? Notice, by the way, people, I still wrote down equals to 0. A lot of people forget that, and then you change your equation to an expression and you lose half a mark. Okay? So you have to write down this equals 0, otherwise you lose half a mark. Now, look what happens. We want to solve what's inside the brackets. Do you remember how that works? We would have done this, 3x plus 1 or x minus 1 equals 0. That means x can equal 1 or negative 1/3. Do you remember how that goes? Right? The opposite sign of this divided by this number. So that means sine theta can equal negative 1/3 or sine theta can equal 1. Okay? With me? All right. Now, continuing. That's step 1. Right? We solved and isolated for sine theta. Whichever trig function they give you in the question. Step 2 is what? What was step 2 again? Finding the reference angle. Either by using our chart or by using our calculator. If we use the calculator here, we're going to go second sine, or inverse sine, of 1/3. But our calculator is going to be on radians now. So now it's going to give us a radian measure.
Oh, yeah.
It should give us really small values. Because radians, remember, can only be between 0 and 1.5. And then we're past 90 degrees. Our reference angle will always have to be 90 degrees or less. Remember, we ignore the negative. So what is our reference theta? 0.3398? No, here's the thing. All of your answers have to be correct to 3 decimal places. So you have to put at least 4 on there, because later on when we add or subtract pi, we could mess up one of those decimal places unless we go to 4. Does that make sense? So put down 4. What about this one? This one is actually on your chart, isn't it? Where is sine 1? Where is sine 1? That's up here, right?
90 degrees.
Yes. So this, and in radians that would be?
Half pi.
Yeah, pi over 2. And that's the only place that it's 1, right? It doesn't get 1 again, does it? In the first revolution. Do you agree? So in this one, we could save ourselves a little work using the chart, right? Because that means we won't have to go into all soup turns cold stuff. Because if you look on your exact value chart from yesterday, sine is 1 at pi over 2. Oh yeah, no. So this goes to this branch, and this one's going to this branch, right? Does that make sense? So this means our final answer for this branch is theta equals pi over 2. So we're done with the right side branch. Agreed? Okay, now let's work on the left side branch. What are we going to do with that one? Well, what's our next step? This thing, right? All soup turns cold. So in all of these questions, unless you're using your exact value chart, you're going to have to go here, right? All soup turns cold.
So, is that the actual reference angle?
This point 3398?
Yeah.
Yes, exactly.
Oh, so
It's just like we did with that one before with the 53.13 degrees, right? We're just using this number instead. So we're going to go where sine is negative. So that's 3 and 4. Good? All right. And then we're going to give number 4 final answers. All right? And remember, at the beginning it said between 0 and 2 pi, right? Did I do it like that without a equal sign? I can't remember what I did. Yep. Okay? So if pi over 2 was one of the answers, we could not, or if 2 pi was one of the answers, we could not include it, right? Following that? All right, so what are our final answers? Well, we did have theta as pi over 2. How do I get this answer? Yes, except instead of 180, we're now going to use pi, right? Because we're working in radians. Right? Does that make sense? So it's going to be pi plus 0.3398. Is that right? 3.45? Maybe not.
3.481.
3.481.
Oh, 48, yes, right. Yeah, I got it mixed up there. I got a 0 there. 3.481. And then what was the next number?
4.
4? So here's the thing. This is a good habit to get into. They always want you to be right to 3 places. So if you write down 4 places, they'll always mark you correct to 3. Because you can't be wrong to 3 now. So even if you rounded this, like if this number had been a 3 instead of a 4, because of rounding issues, was halfway, you'd still be right to 3. You know what I'm saying? So always write down 4, and then you're going to be totally correct to 3. Okay, and then this one is going to be 2 pi. So this was pi plus 0.3398. And this is going to be 2 pi take away 0.3398.
That's 9433.
433? Okay, good. Those are our answers. Pretty good, right? Same system every time.
5.9.
Good. Okay, last question. What if I have something like this? Solve for theta between 0 and pi. I'll get over here. Cosecant squared theta. Let's see. I'll be there in a minute. I'll make it 5. Let's go. Hey, write that one down. I think that, yeah, that'll work. Yep, I like it. Okay. Okay, so same thing, same steps, right? People? Solving the same steps, right? Okay, let's look at it. What's our first step? Tanner, what's the first step?
Factor.
Factor, okay, so we're going to factor 5 cosecant theta, 1 cosecant theta. Again, a 1 and a 1, right? And again, this is going to be a negative, and that's going to be a positive. Okay? With me so far? Okay? So, we factor, and then we solve for cosecant theta. Got to get it by itself. You guys watching? So this is going to be cosecant theta must equal negative 1 over 5. And this branch leads to cosecant theta must equal 1. Right?
Oh, yeah. Yeah. Okay, yeah.
Okay, well, we don't have any cosecant buttons on our calculator. What are we going to do? Find the sign, flip it around. So we're going to have to use sine instead. That means if cosecant is 1 over 5, then sine theta will be negative 5 over 1. Do you agree? Okay? And here that means that, oh, when you flip 1 over 1, I guess it stays the same, doesn't it? Right? 1 over 1 is still 1 over 1. So it didn't change it. Okay. Our next step is to find the reference angle. Okay? Try it on your calculator. Ignore it. So you're going to do the inverse sine of 5 over 1. It's still on rads. Because of this, right up here, right? Still on radians. Good, you get an error. Did everybody get an error on their calculator? What does that mean? Tanner? It's not possible. Think about what sine is. Sine is the opposite side divided by the hypotenuse. How could the opposite side be longer than the hypotenuse? Because the hypotenuse is supposed to be the longest side.
Just straight that it doesn't work.
Yep. You can write down no solution. You can't just write down error. They won't give you a mark for that, because that's just what your calculator tells you. So you have to say down no solution. And what about this one? Where is sine of theta 1?
Sine is 1.
At half a pi. We just did that one, right? So this one only has that as its final answer. Okay? Everybody good?
Is this the hardest? So there's only one answer.
It's often the hardest unit, but it's pretty good so far, isn't it?
Yeah, so far.
Usually, I'll tell you what usually happens in this unit. Everybody does really well from assignment to assignment. They all get it, and then when they have to put it together, some people think, oh, I understood it all, I don't need to study. But when you try to put it all together on one page, they get confused, right? So, but we'll have a review, so you'll have a chance to go through that process. But that's kind of what happens in this one. Individually, the stuff is all pretty good. So, key points, people, right here, right? That's what you do. Those 4 steps every time, right? Solve the equation for whatever trig function. Find your reference angle. Go into all soup turns cold. State your final answers according to the restrictions they've told you, whether it's in radians or degrees. Good? Okay, it's assignment 4. There are just, you know what? Let's see. Yeah. There are 6 questions there. One of them doesn't have an answer, by the way. Well, there's quite a few more questions.